Cloud security challenges. In this presentation, I will talk about cloud service models, cloud deployment models, the shared responsibility model, the main cloud security challenges, and how we can reduce these risks. Cloud security models, challenges, and mitigation. Today, I want to talk about cloud computing and security challenges inside it. Cloud computing means that instead of buying our own hardware, we use computers, storage, and software through the internet. It is very fast to set up, easy to expand, and cheaper at the beginning. Because of these benefits, many companies moved their systems to the cloud. But when we move to the cloud, we must know something very important. We must understand what part the cloud provider protects and what part we must protect ourselves. If we do not understand this correctly, we may leave our system open to attacks. Services and deployment models. There are three main service models in the cloud. First, IaaS, Infrastructure as a Service. In this model, the provider gives us basic resources like virtual machines, storage, and networks, but we must manage the operating system, updates, security settings, and applications. This model gives us more control, but it also gives us more responsibility. Next, we have PaaS, Platform as a Service. In this model, the provider gives us a complete environment to build and run applications. This includes things like runtimes, databases, and development tools. We only focus on our code and our data. This model is very good for developers because it makes building apps easier and faster. Next, we have SaaS, Software as a Service. This model is a ready-made software that we use through the internet, for example, Gmail. The provider manages everything. Our only responsibility is to protect our account and our data. This is the easiest model for users. Deployment models. These models explain how the cloud environment is set up. Public cloud. This cloud is shared with many customers. It is cheap, easy to scale, but physical control is limited. Private cloud. This cloud is used only by one organization. It is more secure but also more expensive. Hybrid cloud. This model combines public and private cloud. Sensitive data stays in the private cloud and less sensitive data use the public cloud. Next, we have community cloud. This cloud is shared by organizations that have similar rules and needs. For example, hospitals. They share the same cloud environment. Next, we have multi-cloud. This means using multiple providers at the same time, like Google Cloud and Azure. It helps to avoid dependency on one provider. The shared responsibility model. This model explains which security tasks belong to the provider and which security tasks belong to us. In SaaS, the provider handles almost everything. We only manage our data and our user accounts. In PaaS, security is shared. We protect our code and data. The provider protects the platform and infrastructure. In IaaS, we have the most responsibility. We must manage the OS, patches, firewalls, network rules, and system settings. Understanding this model is extremely important. If we do not know our responsibilities, attackers can find and use security gaps. Cloud security challenges and mitigation strategies. First cloud security challenge is misconfiguration. This happens when cloud settings are wrong. For example, some storage buckets that becomes public by mistake, or network rules that are too much open, users having more access than they need, or no encryption enabled. The risk of this challenge is that sensitive data can become public without us knowing. Solution for this challenge is using tools like IaaS, means writing cloud settings as code, or using policy as code, means checking settings before deployment, or using CSPM tools that find configuration mistakes automatically. Next challenge is weak identity and access management. IAM is the system that decides who can access what. Some issues in this challenge are roles that give too much access, long-term access keys, no MFA, and same permissions for testing and production. So, if attackers get the login credentials, they can access many cloud resources, steal data, disrupt services, and move around inside the system. Some solutions for this challenge are using least privilege grant, means only the minimum permission necessary for each role, or using MFA, means enabling multi-factor authentication. Use short-lived credentials instead of long-term access keys, and reviewing access regularly. Next challenge is insecure APIs. Cloud services use APIs a lot. If these APIs do not have strong logging checks, permissions, limits, or logs, attackers can easily abuse them. Weak or unprotected APIs can expose sensitive data and allow unauthorized people to access important functions. Risks include attackers getting access without permission, leaking data, changing things in harmful ways, and abusing cloud services by attacking the APIs. Some solutions for this challenge are using an API gateway to protect APIs. It helps control login, permissions, and limits how many requests can be made. Next, we should use safe authentication methods like manual TLS to make sure only trusted users and systems can connect. Then we can regularly test APIs with tools like DOST, means dynamic testing, and SOST, means code scanning, to find and fix security problems. Next challenge is about data leakage and weak encryption. It means that data is stored or transferred without proper encryption. Sometimes encryption keys are not stored safely. If data is stored or sent without encryption, or if keys are handled poorly, attackers can easily see or steal sensitive information at any stage. This can lead to sensitive data being exposed, breaking important laws, losing customer trust, paying heavy fines, and damaging the organization's reputation. Solutions for this challenge are encrypting data at rest and data in transit, and using secure key management tools like Key Management Service, that is a cloud service that safely creates or stores and manages encryption keys, or using HSM, hardware security module, that is a physical device that keeps encryption keys very safe and never let them leave the device. Also, automate rotation and access control. Next we have DOS, DDoS, and cost-based attacks. It means that attackers send too much traffic so the system cannot work, or they try to increase our cloud bill. So services may stop working, run slowly, cost more than expected, lose money, and hurt the company's reputation. Some solutions for this challenge is using content delivery network. That is a system that delivers website or app content faster by using servers in many locations. Or using web application firewall, that is a tool that blocks bad traffic and protects web apps from attacks to block bad traffic and stop DDoS attacks. Setting limits on resources and cost so attacks don't make bills very high. Having a plan or response ready to handle attacks quickly. Next we have software supply chain risks. The problem is sometimes the software we use, like libraries, container images, or third-party tools, can have hidden problems or malware. If we use them, the bad code can spread through our whole system. So attackers can run malicious code, steal data, get unauthorized access, and affect many parts of the system. Some solutions for this challenge is keeping a list of all software and components we use, that is a software bill of materials, and only use signed and verified container images from sources we trust. Automatically check software for vulnerabilities in our development process. Next we have insufficient logging. It means not keeping proper logs or having no plan for problems makes it very hard to notice attacks quickly or investigate them later. So attacks may be detected too late. It's hard to find out what happened, and rules or laws may be broken. Solutions for this challenge is using SIEM tools to collect logs in one place and analyze them in real time. Keeping logs safe and protected so they can be used for investigations. And making step-by-step plans for responding to attacks and practice them regularly. Next challenge is multi-tenancy risk. In public clouds, many users share the same physical or virtual servers. If isolation is weak, one user could access another user's data. So data might be seen by another's. Trust in cloud goes down, and big security problems can happen. Some solutions for this challenge are use dedicate servers or virtual machines for sensitive data so it's not shared. Keep networks separated and strictly controlled. Regularly test to make sure users are properly separated. And for very sensitive data, use private or hybrid clouds to have more control and reduce risks. Next challenge is vendor lock-in. Sometimes companies rely too much on a single cloud provider's tools and APIs. This makes it hard and expensive to move to another provider. So, if one provider has problems or change rules or raises prices, the company has fewer options and less flexibility. Some solutions for this challenge are building systems using standard tools and APIs so they can work with any provider. and using more than one cloud provider at the same time to avoid depending on just one. And keep good documentation and a clear plan for moving to another provider if needed. Next, we have non-compliant third-party services. Sometimes companies use cloud services from third-party providers that are not fully trusted or certified. These services may not follow proper security or legal rules. So, using these services can cause privacy problems, legal fines, data leak, and failure to follow regulations. Some solutions are check and test third-party services carefully before using them to make sure they are safe and follow the rules. And choose services that have official security certifications like ISO 27001 or COC2. And make clear contract with providers that explain their security duties and how they respond to the problems. Next challenge we have is unpatched software. Some software operating system or container environments can get old and have security problems if they are not updated. Hackers can use this weakness to attack the system. So, old or unpatched software can allow attackers to access systems without permission, gain higher privilege than they should, or install malware and exploit known security flaws. Some solution for this problem is keeping all software up to date by applying security updates regularly. And check system for weakness after every update or deployment to find and fix problems. Also, use cloud services that automatically handle updates and patches so you don't have to do everything manually. Next, we have lack of zero trust. Some organizations trust all devices, users, and services inside their network by default. This can be dangerous because if an attacker gets in once, they can move around freely and access sensitive data. Zero trust means we never trust everything by default and always check every request. Without zero trust, attackers can move inside the network after breaking in once. Insider threats can cause more damage, and systems and data can be accessed without restriction. Some solutions for this challenge are setting up rules that check identity and permissions for every user, device, and service request, no matter where it comes from. And divide the network into small segments and encrypt communication between services so attackers cannot move easily. Also, watch user and system behavior all the time and regularly check access patterns to detect anything unusual. Conclusion and recommendations. Cloud computing brings speed, flexibility, and lower cost. But it also brings new security challenges because cloud environments are shared and constantly changing. By understanding cloud service models, deployment models, and the shared responsibility model, we can avoid many risks. Most cloud problems comes from human mistakes like misconfiguration or weak access controls. If we use strong practice like encryption, MFA, least privilege, monitoring, zero trust, and secure development, we can use the cloud safely.